Hi, my name is Noah, a civil engineering student at the University of Central Florida.
Hi, I'm Monica, material science and engineering at Drexel.
Hi guys, I'm Declan. I study geoscience at Drexel University.
Hi, my name is Pratik. I graduated last year from Penn State.
Hi, I'm Daniel. I study chemical engineering at the University of Buffalo.
And we are here to talk about a project which is about recycled plastic roads. So we are here trying to cater to two types of pollution, which are plastic pollution and asphalt pollution, which are very prevalent in society these days. Looking at the current environmental conditions, the United Nations has put forth like 17 sustainable goals, which are to be catered by 2030, and we are trying to target 3 goals out of those 17, which are like goal number 7, which is affordable and clean energy. So we are trying to produce like hydroelectric power from the storm runoff from the roads. So that caters to goal number 7. For goal number 9, which is industry, innovation and infrastructure. So we are trying to being innovative by using recycled plastic in our asphalt. So that's a quite innovative method of making road, which comes as a part of infrastructure. And the last goal is goal number 11, which is sustainable cities and communities. So we are trying to deliver a sustainable environment where people can live and thrive happily. So let's talk about plastic pollution. So as looking at the current scenario, United Nations have some facts about plastic pollution, which as we can see here on the screen, in 2010, approximately 4 to 12 million metric tons of plastics found their way into water, which is scary. And it is being predicted that by 2050 there will be more plastic by weight in the world's ocean than the fishes. So, which is a thing to think about. Then annually more than 8 metric tons of plastic leaks into the ocean each year, which is equivalent to dumping a garbage truck of plastic every minute. So if that fact is to be believed, by the end of our group presentation, which is about like 15 minutes, there would be at least 50 garbage trucks which would be dumping plastic by the end of it. And lastly, plastics made up 12.7% of the waste stream in 2011, which is up from 10.5% from 2010, which is again, it's ever increasing pollution, so which we have to tackle. And the second pollution which we are trying to target is asphalt pollution, where currently roadway design involves usage of asphalt, which is a product of petroleum compositions, which are basically hydrocarbons. So in order to produce asphalt, we try to burn hydrocarbons which produce CO2, and other harmful emissions, so which are very critical for the environment. And talking about the water pollution, since asphalt is very impervious, so when it's rainfall or snowfall and the snow melts, so the water at the top of the surface, it's not allowed to percolate underneath, so the water stands there and gets stagnated, which is prone to being contaminated by certain air pollutants, which are eventually emptied into our lakes and rivers, so which again creates more pollution. Now, I'll pass on to Declan.
Alright, so our goal with Grate Roads is to provide sustainable solutions to the problems that Pratik just mentioned. So basically what we'll be doing is making prefabricated road structures out of recycled plastics. So the plastics will be mainly using our high-density polyethylene and low-density polyethylene. We looked into using PVC, but because we will be melting down the plastics, PVC releases more the dioxins, and that is a little more dangerous. So basically what we'll be doing is collecting the recyclables, shredding them up, or cleaning them, shredding them up, and then melting them down. Once we melt them down, we're going to pour them into molds, and then throw in some aggregate, the butamine, and then let those dry. Now this is quick, easy, and efficient compared to the asphalt process. We'll primarily be doing this in our factory, and we can do this, we can make many pieces at once. We can do this, it doesn't matter what the weather is outside or what the project is, or having to wait for the construction companies to get the foundation ready. We can have stuff ready to go the minute those roads are ready to go. And it is sustainable, so obviously we'll be using recyclables, and because they're like different parts, which we'll explain in a little bit, for maintenance reasons we can take them out and then recycle them, which makes it more sustainable. And our unique design, we kind of based it off there's not many companies doing this right now, it's kind of a new idea, but our design is kind of based off of that. There's going to be a couple inches and then kind of a hollow space underneath with the piping, and Noah's going to talk a little bit more in depth about that.
Okay, so for our roadway design, as you all know, roadways consist of hundreds, if not thousands of miles of our infrastructure throughout the world. By breaking our design into 50-foot increments, we can more accurately and precisely design each of the road segments to be able to tie into one another. So a good way to think of it is like a three-dimensional puzzle. You have to have each puzzle piece fit in with each other, along with each of the height elements be in the same dimension. So that allows for the geometric design of the road to all fit into each other nicely, all the cross-sectional slopes be continuous, and no construction joints or bumps in the road that you would feel. Like Declan mentioned, our design consists of modular construction, which we would be prefabricating off-site, allows for more efficient construction of this road once they get onto site, which currently asphalt roads take months to construct, and our roads could be put together in a nice orderly fashion where one after another we could be implementing those puzzle pieces and building the road in weeks rather than months. And like I mentioned with the geometric design, they would all fit together nicely, and the hydroelectric rainwater collection culverts would also tie into each other. And instead of, one of the main differences with our roads, instead of having water to permeate off to the side and collect, like what they normally do, our design allows the water to percolate through the roads and to be collected underneath. And if you could, this is a conceptual design that my team and I have come up with and built. This is a generic piece of the puzzle which can be tailored and designed more and more to fit into each of the roadway design segments. It can have more curves if needed, more higher elevations on one side, all in the effort to have the roads be one continuous unit. The green part right there is an impervious layer underneath the permeable asphalt segment right there, which will allow water to drain down and into the collection culverts, which we will then transport this rainwater that is collected to a localized microhydro power turbines, which could power local communities, and Daniel will get more into that. And also, one last thing is the structural support that will be for all the roads. For AASHTO standards and other roadway standards, we need to be able to support the single and multi-axle loading of the roadway components, and by having a mix of earth and backfill along with cement and possibly recycled plastic structural components, we would be able to support the load-bearing ability of the road and use minimal amounts of single-stream waste.
Okay, so for the cost, it's going to cost about $20,000 per mile just for the recycled plastics that we tend to buy. And for the minimal concrete supports, it's going to cost about $750 per mile. The PVC piping that goes under the road that collects the water is going to be about $5,300, and the aggregate that we're going to mix with the raw plastic is going to be $800. The rubber cement that we're going to use to bond the pieces together at the joints is going to be about $530 per mile, and then Daniel's going to talk about the micro turbines that we're going to connect there, and that's about $15,000 each. But we're going to save money overall because based on other plastic roads that are currently being developed and designed, we can estimate that our road will take about 70% less time to produce than a normal asphalt road. Okay, so overall, so we looked at how much a raw asphalt road costs and the finished cost of the road, which is about $4 million per mile. We used that structure factor to estimate that our road costs about $2.8 million per mile. But with that being said, it should install faster than a normal asphalt road, so we should save even more money than that.
Okay, so as Noah said, with our road, we'd like to collect the rainwater that goes onto the road instead of just permeating down off to the side. So we want to collect it, transport it to a turbine, and with that water, we'd like to create electricity to power a small suburban community. So what we chose was to use a micro hydro electric turbine, which is the best for the purpose that we want to use it for. It's reliable, efficient, and cost effective. It's one of the more cheaper turbines on the market right now. And with power generation, it's kind of intermittent because rain isn't always present. There are some days, where there's no rain, and some that there is lots of rain. So we chose to use a Kaplan turbine because it has a more steady efficiency with a larger range of flow rates. So even if there's a little rain, there is going to be approximately the same efficiency as if there was a lot of rain. And so after the water goes through the turbine, we plan on using existing infrastructure to place the water into existing wastewater streams. And then we plan on testing this in Orlando. One of our main concerns was whether or not the pipes would freeze in colder temperatures, so we chose a warmer climate where hopefully that would not happen. And Orlando also has a fair amount of precipitation, which could lead to more hydropower. There are also lots of highway and traffic areas in Orlando, so we're able to actually compare how well our plastic roads do in comparison to the asphalt roads that are currently there. Our roads are easier to maintain, meaning like if something is damaged or if there's a pothole or something, we can simply remove the Lego piece, the Lego road, destroy it, then use the destroyed material to actually recycle and then build the new Lego piece and then just simply place it back, which is very, very efficient. And so we plan on taking plastic from a private company in Orlando that takes in recycled materials, or we could also use other private companies like Oceans without pollution. So yeah.
For our distribution channels, we're hoping that the city of Orlando wants to be more sustainable and advertise that, and will buy our product, which is also cheaper than an asphalt road. Like they said, we can build the pieces off-site somewhere in Florida, and then they fit perfectly on an 18-wheeler, and we can ship them to site and install them where the road needs to be built. Like we said, the workers will install these roads with rubber cement, so no one loses their job. It's the same worker that would have paved an asphalt road, and the installation of the road is faster than asphalt. Like we said, the energy that we produce from the hydroelectric, we're hoping will go back into the community where the road is placed.
Some of the potential problems we might be facing with relating to the design is the permeability factor through the roads. We would have to do further testing to figure out what mix of plastic and aggregate, as well as friction course for the cars to drive over, would work best and be most efficient to capture as much rainfall as possible. And also in the case of a 100-year, 25-year rain event, which we would experience more than anticipated rainfall. So we would also incorporate a spillway system to allow for that influx of rain to tie into the existing drainage system that would just go off to the sides of the road.
Right, so another potential problem we thought about was how much plastic can be bought. So depending on the different kind of projects we get, we're not really sure if the Orlando plant will be able to meet our demand. That's why we'd be able to reach out to private companies, and hopefully they could help us out there. Another thing to consider is how are we going to maintain these pipes? So because they are in these Lego pieces, rather than redo a whole road, we can find that one particular area, take it out, and our pipes will be able to fit like humans in them, so they can do they can be able to do maintenance inside the pipes. And then how to deal with winter conditions. So that was a concern of the freezing, which is pretty much why we chose Florida. And for now, we would want to base our operations, in areas that kind of have the same climate. And finally, the transportation of pollutants. The water flow ties, they're going to go right into the local sewer system. So that's kind of at the discretion of the city. It's kind of out of our hands. But because our road's going to collect water, this is going to reduce and limit runoff. And that's pretty much it. We do think this is feasible. This is kind of a new idea. There's not many roads in the world. I know there's a few companies in Europe that have done bike paths for 100 meters. Nothing on a really big scale. But we do think this is feasible, and I'm looking forward to seeing the potential of this idea, not just with us, but the other companies doing it.
So if you get a pothole on the road, how much hold time would there be in replacing it?
Hold time as in where we could remove that piece.
You would remove it, like how much time would it take for that, a new section of road to be put in, or would you already have a pre-made
So what
section
we
to be put
could
in?
do, it's a great question, is what we could do is have a temporary pothole solution in place that would require further research to do, but we could basically put a Band-Aid over it until the larger piece could be made and then do a more timely and permanent fix to that problem.
So you said that the roads were bonded by rubber cement.
Mhm.
How would you dissolve that to remove the pieces of the road?
Cut them.
Just cut 'em?
Yes, cut them.
So piece where it's like interfitted, and so you'd be cutting a piece of like the other side of the road, or is it just like?
You would just like cut it to make new seams, and then place a piece of the correct size into that seam to fit it.
Okay.
And there would be expansion joints which are connecting like each section. So
It's like a tile.
yeah.
So many cities have their infrastructure built underneath the roads, like power and water. How would that work with your system?
You could still do it with that hollow space that would allow, you know, your electrical conduits and other utilities.
For easy accessibility. Okay.
Would there be any input of microplastics from weathering and erosion, like through runoff and everything?
That is one thing that we have thought about, and we've come to the possible use of a sealant over the road to prevent any sort of fracturing or any of those microplastics from chipping off and then getting into the water stream, which is essentially the problem we're trying to prevent. Yeah.
I'm curious about those seams of the road. So, with the do you have any plans for making it like consistent? Like, wouldn't it be weaker at those seams? So if you just keep cutting it up and then just keep getting weaker and weaker, I'm just curious if you considered what be done about that.
I mean, the whole road is made out of like a plastic aggregate mix, so like the fact that it's permeable, like it already has some give to it. It has the hollow space. So we're thinking that like a seam every mile shouldn't make it as weak as you're thinking it is. Like it's still a pretty thick road. It shouldn't be that big of a fracture point, and the composite is stronger than asphalt, so it won't crack in the same way.
And we're also not doing like you know, a whole stretch of a highway. We primarily be focusing more on like residential development neighborhoods, like, you know, Toll Brother neighborhoods, something like that.
Where we would be able to harness that hydroelectric power and then power the local community.
Would you be custom making pieces? Like I know a lot of roads have like an arc of curvature and they're all very different. Like would you be custom making pieces for that, or would you? Like, how would you deal with that?
So what we would do is we'd work in conjunction with the roadway designers to get their plans, and then we would have to go ahead and figure out the most economical ways to divvy up that road section. So for the curve that you're talking about, instead of having one continuous piece of a curve, maybe we could break that into smaller pieces and have it essentially be more straight lined, but
So you like curve that way, like a hill.
yeah. Oh, so you're talking about like elevation curves.
Yeah.
Okay, so that would be, we would have the elevation curves, we would just have to backfill more of the earthworks to allow for the elevation height to tie in, but that would be more of what would be underneath our existing road.
My question is in regards to implementation, like, is this for new roads that are being built, or can you retrofit it to be implemented in roads that already exist?
It can be retrofitted into existing roads. Ideally, we would like to make all roads this type of plastic composite because of the able to collect and harness the power. But if roads need to be serviced eventually, we can use that opportunity to for the need to the serviceability to go forward and sell our product and really convince people to move forward in the sustainable way of doing things, because that's going to be how to be more efficient moving forward.
Like Brad is.
So, I know that like in Florida, the speed limit on highways is usually about like 80, I think, or 70.
65 to 70.
So, how would these, if cars keep driving on that at that velocity, how does that affect the surface?
Well, like we said, we're trying to do suburban. We're trying to do 2-lane roads. Like that works best with the design we came up with. there's a lot more problems when you get into highways, so like that's why we focused on smaller communities.
Essentially, it's the same thing as an asphalt road. It's just different on what it's made of, and actually, it's a lot more durable compared to asphalt. So it actually has a longer lifespan than most asphalt roads. And in construction, roads do have a lifespan and have to be repaved, especially in these high traffic areas. So it's kind of like the same thing.
And we're
just
also
to
looking
make
for
them-
like ASHTO standards, which are like federal. So those apply to like pretty much the entire nation. So.
In terms of the sealant to eliminate microplastic pollution, do you think that would affect the permeability of the roads whatsoever?
No, because I think we could have the sealant go around the permeable holes that would be in the plastic itself. It might decrease the rate at which it permeates through, but that would require further research for us to figure out the most optimal way to allow the water to get through and prevent the microplastics from fracturing off.
So I just had a question. You talked about how you wanted to plug your system sort of into the sewer system of the city. Who would eat the cost of like getting your pipes into like the water treatment plant?
Like you're saying, like who would do the tie-ins?
Yeah.
I mean,
would that be you or would that be you?
that like depends obviously on like base per base. Like probably us because it's our infrastructure going in, but the city makes money off of our turbines taking the power out of the grid.
Okay.
In the future, do you plan to try to expand into colder climates? And if so, how would you have you thought at all about how you might adapt your design so that pipes would freeze and stuff?
Yes, we have, and I think adapting for warmer locations was a good starting point. And as our company's popularity grows and more research is done, we'd be able to adapt it into the warmer climates or colder climates. My apologies.
Do you have any idea of the rate of infiltration? Like, is there going to be standing water on the road, like potentially dangerous?
Ideally, no. Any sort of standing water that, say we have a high influx of rain, would be diverted off the roads for sort of like a fail-safe spillway sort of thing to allow for no standing water to be on the road. So if anything that can't go through the roads, we'll use the existing drainage structures along the sides to divert the water into those channels.